John. Yeah. Okay. So I'm already live. Okay. This video was will be like the replacement of the other one because I realized the audio is not there in the other video. So we now go. Okay. We now start afresh from where we are. So but it will be like a recap. I won't clean anything. I'll just have a brief recap of how the video went. So, as I said, we'll be using an AI companion called EduLearn. You can go to edulearn.fun and register for an account, and you are good to go. You know, get started, go to chat. Okay. AI study companion, which will learn smarter, grow faster. And okay, so these are basically how the AI works. You pick a topic concerning through natural conversation. Our AI adapt to your learning style. Okay. We now type test. When we are ready, it will trigger a personalized quiz to test our understanding and reinforce key concepts. Then earning XP, and then when we type leaderboard, we'll see where we are ranked among other learners and track our growth over time to stay motivated. Okay, so let's have a brief recap of how the chat went before the other video went out. And I sent a prompt to it. This is the prompt. I said, doing 100 days of Rust programming language project-based learning, a beginner into Rust with just the simple knowledge about variable, data types, functions, just little. I'll start to create a project which I am beginner into, and I was only given the basic description of the project. Make it simple and also friendly as I am beginner. Teach me every concept detailed, and then we move to the building block of the project, and then start building it step by step. So here's the brief description. Here's the description of today's project. I'm sorry, let me be off for a while. Okay, I'm back now. And so, as I was saying, so here is the description of today's project. And the description, I copied the description from the GitHub repo. This is it, created by Library. Always credit to the GitHub creator. And yeah, this is a brief description. It says, given an integer, create a function that returns the next prime. If the number is prime, return the number itself. Example, let's say we created a function called next prime, and we impute an integer 12, a number 12 into it. So since 12 is 12 a prime number, it will ask the program will have that in mind. Is 12 is 12 a prime number? If it is not, then it will go to the next number after 12, which is 13. Is 13 a prime number? Yeah, 13 is prime number, so it will be that. Then we have this one, an example also 24. Is 24 a prime number? Maybe no. So it will move on to the next prime number, which is 29. 24, 25 is not prime number, 26 is not, 27 is not prime number, 27 is not prime number, 28 is not prime number, and 29 is prime number. So it will give us 29. So when I said, if the number is prime, the input, that's the input number is prime, return the number itself. So here we input 11, And since 11 is already prime number, so it will return the number itself. So the AI says, all right, buckle up for your Rose program now. For your Rose, it's awesome that you are diving into project-based learning. That's a fantastic way to solidify your understanding. The next prime project is a classic and great starting point. We'll break it down into digestible pieces. First, let's define what a prime number is. Can you give me a brief explanation of what makes a number prime? So, as I said, to my understanding, prime number is a number divisible by 1 and itself. And it says, uh, okay, yeah, no, no. Yeah, this is the chart we did. Okay, it says that's a great start. You're absolutely right that a prime number is only divisible by 1 and itself. So it awarded me 2 points for my answer. So it now says, now let's think about how we can translate this definition into Rust code. Imagine you have the numbers, let's say 7. How would you check if it is divisible by any number other than 1 and itself? What numbers will you need to test as potential divisors? I said I will divide the number 7 by any other number than other number other than 1 and itself. Let's say 2. So 7 divided 2, there will be a remainder. So if there is no remainder, it is not a prime number. Perfect. You've got the core concept. I've ordered you 2 points for your answer. I said, now let's refine that a bit for our code instead of just checking. Two, we need to check a range of numbers. So if you want to check if 7 is prime, what range numbers will we test as potential divisors? Should we test all the way up to 6, or we can optimize that range? Think about the largest possible divisor you need to check. I think, yeah, we should test all the way up to 6. It says, okay, testing up to 6 will definitely work, but there is a way to optimize it. Programming is always about optimization. Okay, it says, think about it this way. If a number has a divisor greater than its square root, it must also have a divisor smaller than its square root. So, for example, let's say we are checking if 16 is a number here, and the square root of 16 is 4. The square root of 16 is 4. Then we'll now check if 16 has a divisor greater than the square root. Yeah, 16, we know that 8 is a divisor of 16, divisor of 16, and 8 is greater than the square root, which is 4. But 2 is also a divisor of 16, and 2 is smaller than 4. So we only need to check for divisors up to the square root of the number. This will make our code much more efficient, especially when dealing with large numbers. With that in mind, what will be the optimized range of numbers to check if 7 is prime? I said the square root. It says yes. Sorry, I don't know. Okay, I don't know what was it. Okay, yeah, I said the square root. It says yes, you are on the right track. I have ordered you 1 point for your answer. But to be more precise, since we need a range of numbers, what will be the largest number in that range that we need to test as a potential divisor of 7? Remember, we are looking for all numbers. I think here I said, okay, I think the number will be 3, but the square root of 7 is probably 2.65. So the largest whole number we need to check is 2. You got it? So it gave me 2 points uh for suggesting 3, since 3 is very close to 2.65. Okay, it now asks us to start writing some Rust code. I will give you the basic function structure, and then you can fill in the logic. Function, this is the basic function, and I wrote it here. This is the basic function. Just don't bother about this. We'll come back to it later. And this is it. Function is prime. This is the name of the function, and then the input will be collecting. It is n. We name the argument n, and then we expect i32 i32 integer from the user, and then it will return a bool, which is true or false. So it says this function is prime, takes an integer as input and should return true if n is prime and false otherwise. Inside the function, you need to Now it says handle the edge cases, numbers less than or equal to 1 are not prime. Iterate from 2 up to the square root of n. So it says for each number in the iteration, check if it divide n evenly. If it does, n is not prime. Blah blah blah. Then I said I don't understand from 1. Handle the edge cases, numbers less than or equal to 1 are not prime, up to 4, which means the whole thing in basic sentence. So it says no worries at all. Let's break it down further with some analogies and code snippets. So it says handle the edge cases, numbers less than or equal to 1 are not prime. So if n is less than or equal to 1, prime is not prime, so it should return false. That's the code snippet here. So it says iterate from 2 up to the square root of n. So it gives us an analogy. Imagine you are searching for a hidden treasure in a field. You don't need to search the entire field. You can focus on the most likely spots. The square root is like marking the boundary of the area you need to search. So we use a for loop. In this for loop, I wrote it here. I typed it here. It says for I in 2, it will start from 2 up to this limit. This limit is n. We converted n. This as is used to convert a data type. So we converted n to float 64. So it can be a decimal point, as we all know, float 64. Then this float in this bracket, it is the f64 is the float version of n in bracket, but the square root. So we have the square root here, square root of this number here, and then we converted everything here into i32 version, which i32 number, which is what we always needed. Then it says, let's go. So it says, if the loop complete without finding any, okay, we skipped something. Okay, it says, think of division as splitting a pizza. If you can split the pizza into equal slices with a certain number of people other than one or the total number of slices, it's not a prime pizza. So it gave us a code snippet for inside the for loop. Inside the for loop, we should have this. What this basically says is if if the number divided by I is equal to 0, which means the number is not prime, we should return false. Okay. Then it says if the loop completed without finding any divisors, n is prime. If you have searched the entire field up to the square root and haven't found any hidden treasure, which are the divisors, that means the treasure is not there and the number is not prime. So after the for loop, we should return true since no divisors found, so n is prime. Now try putting these pieces together inside the prime function. I'm here to help. So I submitted this. Here's what we did. Function is prime entered to bool, and then I have this inside the function, and then after the for loop it should return true. It says that's a very good attempt, and it awarded me 3 points for my answer. But it says you have the core logic correct, but there's one crucial edge case you are missing: handling numbers less than or equal to 1. I thought about it. I refuse to I refuse to trust my instinct, so I just said I don't get it. So it says let's zoom in on the edge case handling. uh, Prime numbers are only divisible by 1 and themselves, and they must be greater than 1. So numbers like 0 and 1 are not considered prime. Your current code doesn't explicitly check for these numbers. If you input 0 or 1 into your function, what will happen? I tried doing it here. I tried doing it here in the main function. Let num equal to 0. Let result equal to I call the is prime function here, which I inserted this num into it, and it printed true, which is not supposed to be, because I did not specify in the code. So it says to handle this, you need to add a condition at the beginning of a function to check if n is less than or equal to 1. If it is, you should immediately return false because those numbers are not prime. Can you add that check to your code? And now I did this. If n is less than or equal to 1, return false as it says. Excellent. That's exactly what we needed. Okay. Now, it says, now that we have the is prime function, we can move on to the next prime function. Can you outline the steps we need to take to implement next prime function, which find the next prime number greater than or equal to the input? I said I don't really know. I don't really know. So it says no worries. Let's break it down. Here's okay. Where is it? So I think I skipped something. Okay. I don't really God. I said I don't really know. So it says no problem. Let's break it down step by step. Mm. The next prime function takes an integer as input and should return the next prime number, either the number itself if it is prime or the next prime number greater than it. Start with the input number. Check if n is prime using the is prime function we just created. Uh, if n is prime, return n itself. If n is not prime, increment n by 1. Repeat steps 2 to 4 until you find the prime number. Return the prime number you found. Does that make sense? Let me know if you would like to elaborate on any of these steps. I said I don't really get it. Elaborate more. It says, okay, let's walk through it with an example. Let's say our input number n is 12. We start with n equal to 12. We check if 12 is prime using our is prime function. Is prime 12 returns false because 12 is divisible by 2, 3, 4, and 6. Since 12 is not prime, we increment n by 1. So n becomes 13. We check if 13 is prime using is prime 13. Is prime 13 returns true because 13 is only divisible by 1 and 13. Since 13 is prime, we return 13. So next prime will return 13. Now let's say our input number n is 11. We start with 11. We check if 11 is prime using our is prime function. Is prime 11 returns true because 11 is only divisible by 1 and 11. Since 11 is prime, we return 11. So next prime 11 will return 11. Do you see how the algorithm works? We keep incrementing the number until we find a prime. Now, how would you translate this into Rust code? What kind of loop will you use? I think we will be using loop. Yes, you're absolutely right. We'll definitely need a loop. I have added you 1 point for your answer. Now, the question is what kind of loop will be most suitable here? Will you use for loop, a while loop, or something else? Think about the conditions under which the loop should continue. What needs to be true for us to keep searching for the next prime? I said this loop here, the normal loop. I see what you mean. Loop is a valid option here. It creates an infinite loop, which is useful when you don't know in advance how many times you need to iterate. I've ordered you 2 points for your answer. So, how would you implement the function using loop? I mistakenly typed loop. I wanted to type in the code, the whole code, but when I typed loop, I clicked enter. So, it just submitted the code. So it says you are starting the loop, which is good. Now inside the loop, you need to do a few things. Check if the current number n is prime. If it's prime, return it. If it's not prime, increment n and continue the loop. Can you translate these steps into Rust code within the loop block? I'm here to help if you get stuck. I said I don't really know because so it says no worries. Let's break it down. Here's how you can structure the code inside the loop block. Loop if it's prime n, it will check. If it is prime, return the prime number. If it is not, it will increment. So it says if is prime n, this calls the is prime function we wrote earlier to check if the current number n is prime. It will return n. If is prime n returns true, this line will execute and the function return the value of n, which is the next prime number. N plus equal to 1. If is prime returns false, the line will execute incrementing n by 1. This moves us to the next number to check. Now you can put this loop block inside a function called next prime that takes an i32 as input and returns an i32. Remember to include the prime function as well. So we have already seen it. And in our Rust playground, I says, yeah. So we need to have it here. We need to have the loop here. So let me type it for a moment. If is prime, return n. Else, we don't need else statement actually. So else, so it will increment n by one. So n plus equal to one. So it will add one to the number we specified, and if that number two is not prime, it will add until it find the prime number. So now let's move on. I don't need this main function for now. Now let me copy my whole code and then send it to it. This is the code we have. So now it will read out and see if we have any errors and then specify something. And it will also award us some points. That's fantastic. Your code is clean, well structured, and perfectly implement the next prime function. It awarded us me 5 points for the answer. So it says you have successfully completed the next prime project. You have demonstrated a solid understanding of prime numbers, loops, and conditional statement in Rust. Now that they have finished the project, are you interested in exploring any ways to optimize the code further? Or do you want to move on to a new project? Perhaps you could explore different approaches to generating prime numbers, or maybe dive into a different Rust concept altogether. Let me know what you're thinking. But now, let's test our code to see if it works yet. So, function main, then we have let num equal to 12. Let's see, 15, and let result equal to next prime. Then we specify num here. So we print ln. The result is results. So let's run. Okay, I think it says cannot assign to immutable argument n plus equal to 1 cannot assign to immutable argument. Consider making this binding mutable. So now let's go back to x prime and then make n here mutable. So the result is 17. Now we give it 15. 15 is not prime number, 16 is not prime number, and to give us the next number, which is 17. I hope. Yep. So that's what we actually needed, and that's the end of the code. So let's do something very great now. Let's test our understanding. So in the code, in the chat, you can just type slash test and then click enter. So now what will happen is it will generate test questions for you according to the chart you did. So and see the understanding you have. Now we have 1 minute. What is a prime number? I said a number divisible by one and itself. Why do we only need to check divisors up to the square root of a number when determining if it's prime? Because yeah, because any divisor larger than the square root will have a corresponding divisor smaller than the square root. Yeah, which of the following number is not a prime number? Is not a prime number. 4 is not a prime number. What is the purpose of the is prime function? To calculate the square root of a number, to determine if a given number is a prime number, to find the next prime number after a given. Okay, to determine if a given number is a prime number. Okay, so okay, it says, what is the purpose of the next prime number? To find the next prime number after a given number. Uh, and we scored 100%. So we have an amazing chat with EduLearn. So that's why I'll suggest EduLearn to whoever want to learn something. Now let's go back to our chat again, and then let's type leader leaderboard. This will load the leaderboard, and you can see I'm topping the leaderboard. It's XP. So now is fun learning with EduLearn. I'll keep the link in the description, so you can just directly check it out and stuff like that. So, and also this code, I'll share it. I think, is it possible? Okay, yeah, I'll share it in the description, and it's great having you in the video. Thank you very much.